As mentioned before, we're going to do a deep dive. We're going to dive in about waist deep. Okay, we've got about an hour to cover a lot of great technical content. Welcome, questions along the way. But if we really want to get into the bits and the bytes, I'd probably going to refer you to let's meet outside afterwards if we have to deep dive, because we do got a lot of content to cover. But we're finally going to get into how it works. Okay, which I think I've been hearing a lot of questions in that area. All right, you should all know these by now. We've been mentioning them 3 or 4 times. This is what we're going to focus on. So kind of look at this as my agenda. We're going to do a waist high deep into each one of these areas with a focus on everything from ObjFast over. So specific sections where I'm going to give you architecture and hopefully give you a clear understanding of how it works and how it can actually add value to customer deployments. All right. Quick high level. Rick talked about some of this. A lot of times we did our presentations, we realized we didn't tell people we're a virtual machine. We run on a VM. The storage we use is either in the cloud, VMDK attached to VMware, S3 that can be accessed from VMware, but we are a virtual machine running on inside of one of these 3 environments. I know the question came up earlier. It's designed to be very portable. So when we talk about other clouds, we've done skunkworks. Okay, it's very portable. It can be moved to other cloud environments. This is where we're focused today. We expose the protocols that customers expect. We do not expose native S3 or native object. Okay, NFS, CIFS, SMB, and AFP. I saw some faces in here when I heard that. But really what we're seeing is some multimedia people who are doing a lot of work on Apples or looking for backups or things like that. So not a lot of traction in that, all right? Where it gets interesting, well, actually, if I go back one, if you're looking for a cloud NAS, or what you're looking for is file system cloud NAS, iSCSI, block access, this is our enterprise product with the ObjFast built in. So what we're transitioning from is being more than just this NAS environment. We are an enterprise NAS that has all of the functionality that your premise-based enterprise NAS has, but running in the cloud. So this is our enterprise. So we are a NAS. You can use SoftNAS as a NAS, as a backup to other, as a replacement to other enterprise NASs. What we're focused on with our Platinum is getting to this whole hybrid cloud environment, bringing in our other features like lift and shift and UltraFast and everything else, and going truly hybrid, truly multi-cloud, many to one, one-to-many type of environments. Okay? But the key point I wanted to bring out here again is we're a virtual machine running on top of, a virtual machine image running on top of a virtual machine. Hit this one real quick. I believe everybody in here knows what an enterprise NAS is. We've got all of it. Okay, I'm not going to focus on that. I'm going to focus on what differentiates us, in our product. But again, we are a full-featured enterprise NAS with everything that you would expect from an enterprise NAS. I'm not going to cover the bullets. All right. One thing I do want to bring up, we've got 2 versions of high availability that a user can use for high availability with their data on the NAS. One is our Snap HA, which does duplicate 2 copies of the data. So you have 2 controller heads, 2 copies of the data. We came up with another one called Dual Controller HA for our customers who wanted call it a more cost-effective way of doing HA. So you still have 2 controller heads in case there's a physical failover, but they share the same data on the back end. So we do have flexibility and options for our HA.
Does that work across regions, or is that within?
Not across regions. It was slightly different between, but pretty much it's same region in terms of how you can configure it. But it is not a cross, true East Coast, West Coast type of solution.
Yeah, it's cross.
Replicate is what, Rick.
It's cross zone.
Yes.
So Snap HA is replicating and failing over with a virtual IP that's across multiple availability zones, and then typically customers will replicate to a DR replica that's in a different data center from there.
And for the Azure folks, it would be you would spin up one in each availability zone, or they would both be in the same availability set.
It's within the same availability set.
Yeah. Okay.
Right.
One last question. You will need to do data duplication only for the EBS tier, right? Because for the S3 is not necessary.
Right.
I'm talking only AWS specific, but
No, that's right. And it's same thing for Azure Blob. So, yeah, you still need multiple controllers in case you have a failure in a zone, but the object storage is already highly replicated, and so you don't need to replicate that data. And those will work together with SmartTiers, obviously, but
for the
for block, you have to replicate it. Yeah.
Correct. All right. So moving on, this is one of you've heard of ObjFast. Huge differentiator for us. This is our getting the the block level performance with object storage. Why did we do this? We have customers who will come in with some pretty demanding apps, and they say, "I want to save money. I'm going to use object storage," and then they run it, and then they come back to us and they say, "Hey, you're broke. I'm not getting the performance that my app needs." It's like, no, you're using object storage. So we decided to do something about it. We actually developed some technology called ObjFast. So how many people are familiar with what happens when you overload an object storage environment? How many people have actually tried to push it beyond its limits? What that is what happens is you start driving traffic to object storage, you get backpressure. The object storage at some point will literally tell the NAS, and thus the app, I can't go that fast. So what a normal NAS does, most NASs do, they recover from the error, send it back to the app, or they recover it, and they say, try it again. But that's all they do. So they send it back off, it starts pushing stuff out, they get the error again. Well, what's happening on the application side, the app is backing up. He's trying to go fast, but all the NAS is doing in this case is saying, I'm going to retry it, and you end up with this huge bottleneck, and eventually it stops. All right? And what the customers come back, and one of their only choices at this point is to move up to more expensive block storage to get the performance they need. All right? What we've done at SoftNAS is we look at the problem slightly different. All right? We'll still get the backpressure error, but instead of just retrying it, we've got some heuristic algorithms that will actually look at what's really happening. How much backpressure are we now underperforming? And we'll actually tune the speed at which we're accessing the object storage. We'll slow it down for a little bit. Keep monitoring it, saying the back pressure has lowered, I'm going to speed it back up. And we stay in this continuous loop of constantly monitoring how fast at any given point in time can we drive the object storage. We're going to drive your object workload as fast as the back-end object will let us do it. This is patent-pending technology for us. We're the only ones doing it. And the performance impacts are pretty dramatic. All right? So benchmarks, good.
What's the use case of this? Is this optimizing costs when your object storage isn't fast enough?
Correct. If you go to most NASs and you have a higher performing application, there's always going to be apps that still need block storage. There's a lot of apps that are paying for block storage because object just isn't fast enough with normal implementations. With our ObjFast implementation, we have a lot more applications that demand higher performance. We're giving you the best performance possible in the industry by accessing object storage.
That's a lower price point.
Lower price point, yes.
So you're acting as like a smart cache.
You can think of it that way. I think we're acting as a kind of a smart object NAS. Okay. Because again, the key to what we're doing, which really differentiates, is we're constantly monitoring the state of the object, the physical object storage on the back end. Can I go faster? Can I go more gambler algorithm? Oops, I'm seeing some traits that say I'm going to overload it, and I want to avoid all those back pressure errors. What slows object down when you overdrive it is recovering from all the back pressure errors. So if we can eliminate those back pressure errors and always figure out the sweet spot on how fast we can go, that's what gives us the performance.
So Adam, let me add. So one of the challenges with just a typical delay a few milliseconds and retry is that you're in a multi-tenant object storage environment. So you may be getting, let's say, 1,000 IOPS this second. The next second, there may be 3,000 IOPS available. And then the second after that, 5,000. The second after that, 500. So you've got to quickly figure out how to adapt to the available IOPS that are out there without overrunning the back-end system and causing congestion, essentially. So our algorithm automatically figures out what it can do. It kind of pushes, as Adam said, until it starts to see that we're getting the back pressure, and it figures out over time how to actually predict the maximum throughput rates that we can get without causing the problems.
I just wanted to add here is that we are talking about S3 here, or
Azure Blob.
Right. And one of the basic things is that systems are designed to align with S3 being eventually consistent, not immediately consistent. So do we actually have this problem that you're trying to solve?
Absolutely. This was developed based on customer feedback and what they were seeing when they tried to use Object and they overdrove it. This overcome that. So,
But when they overdrove it
But I think to answer your
intentionally, right?
Yeah, so there's different problems. One is the performance throughput, right, to get you block level, hopefully, performance when it's available in S3. The other is the eventual consistency. We solved that in some different ways that we're not really going into, but we definitely had to solve that too.
right.
And because there's times when you put a write out there and you go back to verify the write's there and it's not there yet, right? So we have to solve for that too. That's actually part of all this.
Right.
It's not
It's part of our ObjBacker, where the ObjFast.
because you got to make it reliable in addition to being fast.
Right.
But just for the sake of completeness, why not, in this use case, we're using object storage for something that requires block.
That requires
not-
performance. Yeah.
Exactly. Why not then use something that's actually built for those performance characteristics, those storage protocols? This feels like trying to marry two things that aren't compatible.
Well, so there's times where you really do need block storage, like Adam said, and that's the right tool. There's other times where saving money, I mean, we have customers tell us, hey, if we can't get this to work, we can't really afford to move stuff to the cloud. It's just the cost of block storage and SSD is too high. And it's not really justifiable because we're not really accessing the data constantly. It's more of an archive use case. But when we do need to pull data in, we need it to go as fast as possible. So, it's just, and it varies. And the problem is customers do have trouble choosing between when to use block and object, hence SmartTiers that figures that out for them.
Yeah.
Right?
So one of the
SoftNAS can support both the object and the block in the same environment as well. But quick benchmark numbers on your right side over here is some benchmarks we did. Small, medium, and large is just a reference as to the size of the instance. Think like an M5 large, M5 extra large. I believe it's a C5 extra large. No, excuse me, a C5 8 extra large or 9 extra large to the right. Okay? These are the random read numbers we got. We'll just take the large at 586, and over on the other side it's 599. These are the random read benchmark numbers that we ran. And again, the whole purpose of these slides, that was a throughput. This is an IOPS. You get the throughputs with the IOPS. And you keep the IOPS numbers up by avoiding those back pressure errors and always tuning towards what the back-end object storage can do. Okay? Moving on. John's hit SmartTiers, so I'm going to take a different angle on it. All right, I'm actually going to show you how easy it is to configure SmartTier. Part of the keys, again, is aging policies, which is basically how old the blocks of data are before we'll move it from more expensive to less expensive storage. And then the rehydration as well. So when you set up a SmartTiers volume, the first thing you do, and got an Azure guy over here, so this will work out for him, you have to allocate the physical storage, that's the cloud storage that's going to be used. So in this case, we're going to allocate some, premium SSD. Let's say in this case, we're going to use some hot blob and cool blob. Okay, the first thing you need to do is let SoftNAS know that is the physical cloud storage that we're going to be using. The next thing you do is you wrap it in what we call a tiered pool. This is what aggregates all that physical storage and gives us a virtual representation. All right? Each tier is allocated and you choose what portion of that physical storage you're going to use for that tier. Once you have that tier set up, you can actually go in and set up the tiering policies. This is the actual UI where in seconds, you state how long a block of storage lives in that tier before you move it down. Okay? For each tier. This is the reverse migration. How long it can sit out there, and how often it's accessed before it moves back up. And the other key is you can set what I call aggression algorithms. how often do you do the migration? If you're copying data for the first time into a tiered pool, you might want very aggressive policies to have it flush very quickly because you're migrating the data. And all the data will be going to that hot tier quickly. All right, so we handle that as well. Once your data has been migrated to the tiers, then you can reset to production level, aggressiveness to get your data back into that hot tier, the actual, active working set. All right, so once you've created this tiered pool, that's when you actually use the pool to create the volume. John mentioned this. The application or the user that's actually looking at this is totally abstracted away and doesn't know this tiering's happening under the covers. They don't have to go out. Your app doesn't have to know about the tiers. Your users don't know about the tiers. Okay? So, and this is our standard user interface for creating a volume from any type of pool, tiered or not. So for our users, this becomes very familiar for them because the first step and the last step of 3 hasn't changed at all to them.
So
Okay?
a little segue into the UI. What kind of UI is this? This is a
Web-based.
web-based UI
Yes.
running on the controller heads.
Yes.
Okay.
Great question. Okay, but again, the key is with this tiering, once your admins, your DevOps have configured all the tiering policies, it just appears as a volume, as an export, as a share or whatever, to whatever's using it, and all the magic with the actual tiering happens in the background. Nothing manual to do.
Good question. So, what's the administrative overhead on something like this? Is there a lot of training that needs to get somebody brought up to speed on how to use this?
I don't think so, because literally, if we go back through again, allocating storage, this is pretty quick. I was trying to see in here, this is Blob, typing the credentials that you're usually using in Azure, your keys to allocate it, that should be somewhat familiar to them. Step number 2, the creation of this pool, we make it pretty easy to map back from the physical storage actually into the different pools tiered. Setting these policies, if you click the little help button right here, we actually give you the seconds conversion. So we're giving you a lot of helpful information along the way. So I don't think it's going to be a lot of overhead for them to understand once they get the concept.
That requires like a service to come, have somebody set it up for you, or have like a professional services kind of deal.
If you're a larger enterprise, you're probably working with one of our SAs who's going to be working you through the best practices anyway. And there's videos. And there's videos, correct. There's going to be this video. But there's specific videos on how you can set all this. In fact, if you go into a lot of the little, we call them quick helps, we actually have links to embedded videos specifically on that topic.
And all of these are scriptable actions as well, right?
Correct. There's the REST APIs for all of this. Our entire UI that we use uses our own APIs to build the UI that can also be done programmatically. All right, moving on. UltraFast. All right, what's the problem? I got massive amounts of data over here, halfways around the world. Some of these factories are in an Indonesian village that they've never thought about how do I get all this analytics data and IoT data back to where somebody can actually use it. All right, so how do I get all this data across this slow network back to where my actual analytics guys are? The data's over there, my guys running the apps are over here. So this is the first part of this journey I'm about to take you on, building you through our data platform, starting with UltraFast. All right, this is the flattening that Rick told about. So, I think everybody here probably understands that when you start adding packet loss or latency to TCP, it's a down and to the right, which usually is a bad statement in any industry, down and to the right. Your performance starts to nosedive. So again, what UltraFast really does is actually the higher the latency and the more packet loss you get, the better UltraFast will actually perform, because that's what it overcomes, the 2 primary things that it overcomes. Running on UDP, I think most people understand the benefits of UDP and how it's used in an environment like this. All right. Marketing term, 20 times faster. Why do we use 20? When we take what we consider to be the worst network that somebody actually might use in a real corporate environment, it's giving us about 20%. Okay? We've seen up to 60% with our emulators, but we don't think anybody would ever use a network that bad that will return that 60 times performance. So in general, if you're thinking of a really dirty, like satellite network oil rig back into Houston, Texas, where it's just really dirty, you can get up to 20x the return across the UltraFast. Simple configuration. Net is we'll drive that pipe as fast as it'll let us. They use similar algorithms to like we do with UltraFast, where we're constantly saying, how fast can I drive this thing? Did the pipe just get bigger? The sunspots went away. Now I can go faster. We will constantly monitoring how fast can we go with this and drive the pipe as fast as we can. All right. UltraFast is not a generic WAN optimizer. Coming from Citrix World, it's not a NetScaler. It's a feature that's integrated to the types of solutions that we're targeting, that we're talking about here today. Specifically, UltraFast is integrated with our snap replication. So if you're snap replicating, across regions, UltraFast is integrated into the product that if you want to set up a snap replication cross region, SoftNAS is already integrated. You can just simply say, use UltraFast with the snap replicate. It's also integrated into flex files and lift and shift. Okay, but that's the two areas that we have UltraFast exposed today. It's not a generic WAN optimizer. Okay. Simple configuration. You go to where the source data is, you point it at the other SoftNAS node on the other side. And you give it the credentials for that other side and it remotely configures it. Once you've remotely configured it, we give you a speed test. Classic like DSL speed test. We show you with UltraFast now configured across point A to point B, SoftNAS Platinum to SoftNAS Platinum, what's the difference download, upload, TCP in red, SoftNAS with UltraFast in blue. Now if you're running over a high-end network or Azure Region 1 to Azure Region 2, this might look pretty flat. Okay, so it'll also show you the cases where UltraFast may not help you because you don't have high packet loss or you don't have high latency. Okay, but if you're on that dirty network, that oil rig across the satellite connect, you're going to see a big difference. And that gives you the indication, again, you've just configured it, expect some pretty good results if you're snap replicating or using like our lift and shift technology. All right, you can configure how much bandwidth UltraFast will consume on your network on a 7/24 basis. So you may want to tweak it back during business hours, saying during business hours, I don't want UltraFast flooding my network, with this big replication job because my other users are going to complain. But as soon as they go home at 8 in the morning or 6, crank it back up and let my other jobs, go as fast as possible and consume all of that bandwidth possible. My folks are home sleeping at that point. So very configurable in terms of when it runs. While it's running, we have a dashboard that'll actually give you your real-time stats that you can configure. Yeah, I sped it up for this. Also, it's not real impressive. It sits there for 5 minutes before it updates. But we do have a dashboard that'll give you different statistics so you can monitor what type of performance you're getting with UltraFast while it's running.